Hey, good morning, fourth graders. This is the lesson that we did with our live Zoom. Lesson 8.4, Extending Line Symmetry. We're going to be looking at pages 280 and 281 in your math journal. And then I'll go over your math boxes, which are on 284. We're going to do this lesson in 2 days. So I'm only going to assign part of the math boxes today. And then I'll also let you know what your assignment is for this week. So if you remember with symmetry, symmetry is where you can fold an object on a line and it's the same on both sides. So if you take a look, they give you this example. For each pattern below, I'm going to see if I can make it just a little bit bigger and still fit everything on. For each pattern below, use a straight edge to draw all the lines of symmetry and record the number of lines of symmetry. So for today, you probably don't need any scratch paper, but you are going to want a straight edge. Now a straight edge doesn't necessarily need to be a ruler. It could just be something that has a straight edge to it. It can be anything that you can find at home. A piece of cardboard that's straight or anything. I don't have any other ideas. I'm not that creative, I guess. But if you look, the first thing they show you is this pinwheel pattern. And what they're showing you is that if there's no color in this pinwheel pattern, it could have vertical symmetry. If you fold it, this point will come to this point, and you would, you can see that this square, essentially, it's a square but turned sideways, would match up perfectly from here to here. And this line would cover that line and so on. But you could also have horizontal symmetry. Much in the same way, this point would come up to here and you'd be folding along that line. It also has diagonal symmetry because it's a square. If we fold it that way, then this side right here would come up and touch this side, and this line right here would cover this line. And because it has horizontal symmetry that way, it also has horizontal symmetry that way. For a total of 1, 2, 3, 4 lines of symmetry. Now, if you take a look at this next one, they colored some of it. And they're telling you this time there's only 2 lines of symmetry. And the reason for that is, if you went with horizontal symmetry, that's not a very good line. I blame the bump on my smartboard. If you look at this, if you fold, this part of the color is going to end up being up here. And this part of the color is going to end up here. And the white triangles, at this point, if we fold right there, these 2 points are going to come up here. So you do have the horizontal symmetry. You also have the vertical symmetry because the same type of deal. If I fold this way, this point, we're folding on that point, these 2 points are going to come over here, and this part of the triangle, this smaller triangle, is going to cover up this one. This triangle is going to cover up that one when you fold it. Now you don't have the horizontal symmetry of the first one anymore because if I go horizontal and fold it like this, the colors aren't going to match up. This part of the color, this white is going to go here, this gray is going to go down here, and then the colors don't match up. Remember, it has to be the exact same on both sides. And if you look at both sides, this has 2 pieces down here, but these, it's like, if you look, there's 4 pieces to each of them. This one goes, if you start at the top, gray, gray, white, white. And if you start from the top here, it goes white, white, gray, gray. They're like opposite. And it would be the same if you went with the other ones. This only has 2. Now this time, when they've colored it this way, they're telling you there's only 1 line of symmetry, and it's vertical symmetry. Why you don't have the horizontal is because this triangle is different than this triangle down here. If you were to fold it, and we have these grays here, that also wouldn't work. But if you look, if you folded it this way, this part of the triangle, this point would come to here, so this gray would cover up this gray, and if you look, this corner would come to this corner, and you'd have the same type of symmetry. The last one doesn't have any symmetry because of the fact that they rotated. If you look, they go horizontal, vertical. The triangles are touching horizontally, touching vertically, horizontally, vertically. And if you folded that, if you folded it this way, this triangle would go there, this triangle would go there, and this triangle would go there, this one would go there. If you go horizontally, this is going to match up there, and you can just kind of see there's no way to do that. Well, that's what we're going to look at going forward here. The first thing that they want you to do is to look at the bow tie patterns. And if you look at this first one where there's no color, same type of deal as this. You would definitely have horizontal symmetry. You definitely have vertical symmetry. So we at least have two. But is there more symmetry to that? That's where you need to use your straight edge the best that you can and draw a line from this corner down to there. And decide that's not a perfect one, but same thing on this side. I'm going to try and do a little better job. Would you have diagonal symmetry? You go ahead and draw those and you tell me what you think. Now your line should go straight from corner to corner best you can. And what did we decide? Yes, it would have horizontal symmetry because if you go straight through, you're splitting this square, these squares, perfectly in half. It should be going right through the middle of the squares. So with no color, this should have 4 lines of symmetry. When you look at this one, at the next one, let's see how many lines of symmetry this guy has. Okay. If you fold right there, this square is going to end up here, and this square is going to end up here. So the colors there, are you going to have vertical symmetry? The answer is no, you don't have vertical symmetry. How about horizontal symmetry? If we fold on this line, if I took this top and folded it down, this spot's going to go there. This spot's going to go there. So you'd have gray on white. Is that going to work for symmetry? No. So now we got to check to see if it has diagonal symmetry. We could go this way. And if we do that, think about it, we're folding on that line. So it's like I'm taking these two corners and putting them together. So if I take this corner and put it up here, this corner is gray, this corner is white. This spot right here is going to end up right there. And you can see that the colors wouldn't work out diagonally that way. But we do have one more diagonal to check, which is going, ooh, that's terrible. Terribly drawn line by me. That's about as good as I can get. Alright, now let's check this out. This time I'm taking this corner and putting it down here. And if I did that, this is going to match up here, because it's whatever right across the line the same distance away. This is going to match up here. If this point goes here, this point is going to end up right there. So do we have diagonal symmetry for this one? The answer is yes, we do. We do have diagonals. So there we only had one line of symmetry. Alright, take a look at this next one. Try and figure out how many lines of symmetry you think this guy has. I would start by doing vertical. If we fold there, is it going to work out? And the answer there is no, because these two would go there, and that's automatically a no. How about horizontal? If we do that, this whole white square is going to be going down here. Can that work? No. So now let's check the diagonal. If we go that way, this white's going to go there, this white's going to go there, this whole white square is coming down here. That one looks like it'll work. Let's try the other way. Okay? If we fold this way, we're folding from here, this point's going to come up here. This white piece is going to match up with this white piece. This white side of the square is going to match up with this white side of the square. This white side of the square is going to match up with this white. So how many lines of symmetry does this one have? 2. Alright, so now taking a look at this one. If we go vertical, that means this piece is going to go over here because we're folding it, we're taking it here and folding it over. It's going to go there. And this piece is going to go there. Does that one work? No. Vertical symmetry is not an option there. How about horizontal? Okay, that would mean this point's going to here, this point's going to here. And if you did that, this white piece goes down here, this gray piece goes on the white. Is horizontal going to work? No. So now we look at the diagonals again, which is not the easiest to draw with the smartboard. If we do that, this point's going to here. And this would go there. Opposite side, gray to gray, gray to gray. That one, how does that one look? I think that one is going to be a line of symmetry. Let's take a look at the other diagonal now. Same deal. Now this corner is going up here. So this square is going to match up there. It's not really a square, it's a pentagon. And this piece will go there, this piece will go there. These grays match up. That one looks good. So 2 lines, again, they're diagonal. Let's move on to the Ohio star pattern. So, taking a look at the Ohio star pattern. When there's no color, again, if we start with the vertical line of symmetry, to me that looks really good because this triangle will match up with this triangle, this square will come over to this square, so vertical should work there. Taking a look at horizontal, this triangle will flip up to that one, this triangle will flip up to that one, this square flips up there. So that also works. Taking a look at diagonals. Okay? If we fold it this way, this square comes up here, this goes here, this goes here. This is going to go there. This square right here is actually going to go up there, and this one will go there. So that's a good diagonal. And last, the other diagonal. If one diagonal worked, in this case, the other one's going to be the opposite that. So here you should have had 4 lines of symmetry. Alright, I want you to give this one a try next. Go ahead and pause me and see how many lines of symmetry you think this guy has. Okay, hopefully you found out how many lines of symmetry there are for this one. If we look at the vertical, does it look the same on this side and this side? You bet it does. So vertical symmetry is good there. Going horizontal, is it still the same top and bottom? Is this part the same as this? You bet it is. Looking at the the diagonals, excuse me, not horizontals. That's not a very good line. Again, doing my best here with the smartboard. If you look at this, this is going to come up here. The whites are going to cross over. That's a good one. And the diagonal here is also going to be good. So this also had 4. Taking a look at the next one. This one's a tricky one. There's your vertical. But what I do is I look. This is okay in the middle. But if I took this, over to here, it's going to go gray to white and white to gray. So does vertical work? No, vertical does not work. Same thing with the horizontal. If you look right here, this gray is going to go to this white, this gray is going to go to this white, and that's not going to work either. So I know diagonal doesn't work. All you have to do is find one thing that proves it doesn't work. Okay, so now if you look at this one, we're good here. White to white, gray to gray, white to white. But what we have to look at is what's going to, and here we'd be white to white. But we got to look at these ones. If I folded this down, okay, this is going to end up being, now this is the hard part to show you, is going to end up right here. So it's going to go double whites to gray and white, and that's not the same. So therefore that won't work. If we go diagonal the other way, it's the same type of thing. What's going to happen is this gray and white is going to end up on this white and white. And that's where you're going to, that's a spot. So this one actually has 0 lines of symmetry. And the final one, poof, a lot of stuff going on in this one. But again, all I got to do is find one place where it doesn't work. And if I fold it here, I've got 2 whites. This white's going to go there, but this white's going to go to the gray. This gray is going to go to the white. So we don't have vertical symmetry. Gray to white, white to gray. Not going to have horizontal symmetry. Now we check the diagonals. All right. Same type of deal. This part right here, where they both touch the outside, are going to come down. Actually, it's not that part that messes it up. It's this part right here. That gray to gray, or gray and white, is going to match up with this white and white. Because it'll go from this point to that point. So there you don't have horizontal. When you go the other way, it's the same deal. Here you have white and gray. That's going to go to this white and white. So this one also has 0 lines of symmetry. So for the sake of moving on, we could look at the pineapple patterns. If you want to do those on your own, you can go ahead and do those. But we're going to move on to exploring print pattern symmetry. And this is the next page in your book. This is 281. It says, some patterns called 9-patch patterns look like they are made up of 9 squares. You can make your own 9-patch patterns on a 3x3 grid. And it tells you to take out Math Masters 307 and 308. And you don't have that, but you do have this page. So it says, now arrange some of the pieces on the grid on Math Masters page 308 to make a pattern. Following the directions, when you have completed the pattern, draw and color it one of the 3x3. So what we want to do is we want to have patterns that have 4 lines of symmetry. And if we do that, then whatever we do on one spot, we've got to make sure that it works for all of them. So if I wanted to do one that's going to work all different ways, I could start by coloring that in. I'm going to do one example with you. For example, that's got near symmetry every single way that I do it. If I split it this way, that way, it's the same on both sides. I can split it there or there. Whatever I do now, I've got to do the opposite of it too. So the middle is a fair ground. But if I wanted to color here, I have to do the opposite of that. But now think about this. That works for this line of symmetry. I guess it's still going to work that way. But you have to do the opposite. So that has mirror symmetry every single way I do it. If I fold it vertically, these are going to go from here to here, here to here. This is going to be folded in half. This will go from here to here, this will go from here to here if I fold horizontally. Diagonally, this comes down here, that covers that, and vice versa. You try and do one that's got 2 lines of symmetry. Or excuse me, 4 lines of symmetry. Go ahead and do your own. Okay, looking at our time, we're running a bit short here. There's a lot of different ones you can do, but I want to go through your math box assignment with you for today, and we'll come back and we'll do more of that. This might end up being a little bit longer math lesson than I thought, but it's time consuming to go through it, and that's fine. Okay, so again, to start with, you're just going to do letter A, you're going to save letter B. Same type of deal as last week. In number 2, we're going to do A and B. We're going to save C and D. You can always pause if I'm going too fast. In box 3, same thing. Do A and D, save C and D. This is just adding mixed numbers. Up here you're just subtracting. So I think you can do those. Over here it says a knitting club collected leftover pieces of yarn. It has 3,450 feet of lamb's wool yarn, 1,488 feet of linen yarn, and 2,568 feet of merino wool yarn. The club plans to donate the yarn in equal shares to the art departments at 6 schools. How many yards of yarn will they get? So what I want you to do there is, and this is going to be one of your assignment pieces. I want to see this. What you should do is add these up and then divide by 6. Add and divide, and that will get you how many feet. So adding those numbers up and dividing by 6 will get you the number of feet that you have. But they want it in yards, so then take that answer and divide that by 3. Okay? So, again, add the 3 numbers, take that answer and divide by 6. That's going to get you how many feet there are. Then, divide that by 3. It should get you the number of yards that you have. Okay, over here, we're again doing, this is just one. It's just a multiplication problem. It's 7/8 times 5. Don't forget to put that 5 over 1. You can do that one. And over here, this is another part of your assignment. Do A, save B. What I want to see this week for a grade, what I'm going to grade this week is, get smaller so I can get everything in. Get a little smaller so I can get everything in. Your assignments are going to be, actually I don't want that one. I'm going to change that. I want B and 4. So for today, do B. Your assignment is to do box 4 and box 6, letter B. Email those to me. Take a photo and email those. Alright guys, I hope that helped. Remember on this, add, divide by 6, take that answer and divide by 3. Alright guys, have a good one.